Good morning. Myself Dr. M. Vijay Kumar. I am going to explain about the measurement instrumentation subject, bridge measurement. So generally, the bridge measurement having in the different form, but in electrically, we want to measure a resistance, inductance, capacitance. We have a different type for the measurement of resistance, Kelvin double bridge, Wheatstone bridge. For the measurement of inductance, Maxwell bridge and Anderson bridge. Measurement of capacitance, Sharing bridge and default D-Shorty bridge. So for the determination of frequency, we are using as a Wien bridge. So the bridge measurement, why it is necessary? It is used for not only the measurement of resistance but also used for a measurement of various components value like capacitance and inductance, etc. The bridge circuit is a simplest form of consist of network of four resistance arm forming a closed circuit. So the principle of measurement is a comparison of measurement method and operate a null indication principle. The bridge circuit compares the value of unknown components with the accurate node. I mean the standard component. Thus the accuracy depends upon the bridge component and not on the null indicator. The bridge circuit, when the no current flow through the null detector, which is generally the galvanometer to bridges used to determine the balanced condition. For the bridge measurement, we have two types. One is a DC bridge, another one is a AC bridge. For the DC bridge are used to measure the resistance already we saw, and the DC bridge used as the DC voltage as the excitation voltage. So here the two types of DC bridges are used, Wheatstone and Kelvin. According to the AC bridges are used to measuring the impedance consisting of capacitance and inductance. The AC bridges used for alternating voltage as the excitation voltage. So the various type of AC bridges are capacitance, inductance, Maxwell, D-Shorty, Anderson, Sharing in the Wien bridges. So this is the basic classification of the bridges. So here the Wheatstone bridge. So the Wheatstone bridge are across the various signal. Some of them are measured by changes in the resistance and some of them are with inductance and capacitance value. So while we are considering the resistance, most of the industrial sensor like temperature, strain, humidity, displacement, liquid level or produces the change in value of the resistance for a variable change. So therefore there is a need for signal conditioning for every resistance sensor. So generally the resistance measurement is divided into three types: low resistance, medium resistance and high resistance. So here the possibly for a few milliohms to micro ohms considered as a low resistance, and for a 1 ohm to 100 kilo ohm generally referred as a medium resistance, and 100 kilo ohm to greater than 100 mega ohm, so that is we call it as a high resistance measurement. So for finding this medium value of the resistance, different method are used. Mostly Wheatstone bridge are used. Bridge measurement, the most simplest bridge network to find the resistance in the DC Wheatstone bridge. So these bridge are very small changes in resistance are to be measured like sensor applications. It convert the resistance change to a voltage change of the transducer. The combination of with these two operational amplifier is used as extensively industry for transducer and sensors. So normally the Wheatstone bridges are consisting of four resistors that are connected in the shape of diamond. The supply source and indicating instrument as is shown in the figure. This bridge are used to find the unknown resistance of very precisely by comparing with the known value of resistance, and also the null or balanced condition also to find the value of resistance. So for this bridge measurement, the balanced condition voltage at the point C and D are equal condition. One of the resistor must be variable. So here for the balanced condition, so the equations is given into the null reduction position. So here the I1 R1 that is equal to I2 R4, that is formed as a equation number 1. For the galvanometer current is 0, so I1 is equal to I3 and I2 is equal to I4, that is framed equation number 2. For considering the battery path as a unbalanced condition, under balanced condition, so I1 is equal to V by R formula, I1 is equal to I3, so E by R1 plus R2, that is equation number 3. Then I2 is equal to I4, the V by R formula, E is equal to V by formula according to the Ohm's law, E is equal to R3 plus R4. So using 3 and 4th equation, substituting the equation in 1. So finally we get into the the R4 unknown value. R4 is the unknown value. So the unknown value R4 is equal to R3 R1 divided by R2. You see the R3 is the variable resistance. So if you want to R3 value, we can substitute the equation and get into the value. We can easily find out the R4 value. So R3 is the changeable one, R4 is a unknown resistance. So we want to find out the R4 value. With the help of R3, R1 and R2 value, we can easily find out the unknown resistance value of the resistance. So this is the Wheatstone bridge measurement of the resistance. So the applications of the Wheatstone bridges are basically is a DC bridge and used to measure in a resistance range in 1 ohm to low mega ohm, and also measured in a DC resistance of various type of wires for the purpose of quality control of wires, and also used in a motor winding, relay coil, etc. And also the telephone companies to locate the cable fault, we are using as a Wheatstone low range bridge measurement. Thank you.